Hello, my name is Theodore Dounas, and I'm here to discuss blockchain for industrial applications, always taking into account that the presentation is positioned towards developers. What this talk is not about any kind of crypto scheme or getting rich quick schemes, and essentially it's always about understanding how blockchain works in industrial ecosystems, but also what kind of steps you would need to take to update your developer knowledge or essentially build a product within the blockchain ecosystem. We will look into in what kind of cases you need a blockchain, why and when, what kind of types of networks you might have on blockchains, and what are the main contenders for development. We will take a look a little bit on smart contracts, and we will end with toolchains and development environments that you can essentially access at the moment. And of course, there will be some space for questions. If you still have some comments, please don't hesitate to put them in, and then I will try to answer as many questions as possible. So why me? I'm essentially an associate professor of architectural and digital culture at the University of Antwerp. I'm an architect engineer, and I've been working with blockchain for construction and various other industrial applications. For example, I've done prototypes for blockchain for telecoms. I'm a certified consensus blockchain developer, and I've also written a guide which is online, which I hope you will find useful, that can essentially take you from knowing nothing about blockchain, but to actually being a very, very, very good developer, essentially. Within my lab, we've developed certain prototypes that deal with the construction or the architecture, engineering, and construction ecosystem. And these prototypes we are now developing for full production and release to the industry. For those of you that might not know what blockchain is, it's essentially a distributed computer network where all of the computing nodes hold the same copy of a ledger. You will also hear that sometimes blockchains are called distributed ledger technologies. So blockchain is essentially one kind of distributed ledger technology where we have a mechanism with which all of the nodes within the network arrive at a consensus. This can be with, say, proof of work like Bitcoin, but there are other mechanisms that you can also arrive in consensus on that level. So there are proof of stake or other mechanisms like proof of authority and so on and so forth. The reason why blockchains are named blockchains is that transactions within the ledger are packaged into blocks, and each block contains the cryptographic hash of the previous blocks, hence creating essentially a chain of blocks and so on and so forth. Now, certain of the ideas around blockchains is that they are immutable, right? So whatever you write on them essentially cannot be deleted. You can maybe deactivate it, but not delete it. They act as cryptoeconomic systems. So people who participate in blockchain by maintaining a node have a financial incentive to do so. And also, when we talk about public blockchains, there is a certain level of decentralization. So there is no central authority that guards or coordinates the system. Blockchains are really good for certain industrial problems, and these are the kind of 11 questions that you need to kind of respond to understand if, in any case, any of the industrial ecosystems you're working with really need it or not. And this can be also packaged in a much more, let's say, robust framework. And here you see one that is mainly positioned towards construction. And I have to make absolutely certain that you also understand that in certain cases, for example, where we're talking about the need for central databases, right? That's not the case where you use essentially a blockchain. You need to have questions or needs about immutability of data, no repudiation of data, integrity, transparency, or you need essentially to have equal rights for all participants in the system. So you'll see here we move from centralized on the top to fully public permissionless DLT at the bottom, where you need all 5 of these key aspects. So examples of this might be, for example, complex supply chains. The energy sector comes to mind on that, or other industrial ecosystems where you might have also adversarial conditions between the participants in the ecosystem. And one way to kind of understand how you could investigate whether you would need a blockchain or whether the kind of problem you have can be solved by a DLT is by asking first, would you need to store state? So if not, then don't use a DLT, then it's better to use a database. Are there multiple writers? So do you need essentially not only to store state, but probably have multiple persons having the right to change the state? Can you always use it essentially online as a ledger? Of course. And from that kind of idea, do you know all participants, or would you have completely unexpected participants within the industrial network? For example, within construction, we always have a series of SMEs that we don't know how and when they will participate in a project. A project always comes together from a great deal of smaller SMEs that are not known beforehand. And through that, then you can also decide whether to use a public permissionless or a private blockchain that can be controlled essentially by the stakeholders within the ecosystem that you're working with. However, there are also excellent business opportunities where you can set up digital twins for industrial processes, more so when security and trustworthiness are to be expected from the digital twin of the process. Again, a digital twin of supply chains, for example, might solve a lot of problems with translation of data between APIs or between different databases, but also can allow you to create more or less a more robust ecosystem when you want to monitor through the digital twin complex processes in a lot of different partners within industrial ecosystem. Other business opportunities within this would be the rise of decentralized physical infrastructure, especially in industry. This is really important. And here you have also the understanding that not only you are looking to architect a blockchain decentralized application, but also figure out the token economic incentives that would fuel essentially that network. So, for example, digital sensors on agriculture, energy networks, geospatial networks, and so on and so forth are classic physical resources. And at the same time, you have digital resources such as bandwidth, storage, clusters, compute networks, and so on and so forth. And the combination of the two running on blockchain can allow essentially a new business opportunity to arrive in industrial ecosystems. And here the way it works is that the understanding is that you have a supply side growth that attracts users and entrepreneurs. You have a much more equitable sharing of wealth through the data. That increases the network usage, and then token rewards incentivize infrastructure deployment, and also then goes on to user-generated fees that boost service offerings, essentially. Note, however, that this is much more difficult to build compared to a much more traditional network. So from your point of view, if you want to improve your knowledge or the knowledge of your team, you can definitely look into The companion I've written with my colleague Hiko McDonald, and you can find it here at arkidao.github.io/web3 task companion. And this essentially takes you, this has been written with the basis of the Consensus Academy program, and is essentially a very coordinated set of resources that can introduce you to the subject, cover all of the theoretical aspects, but then also helps you a lot with learning the main language of smart contracts for the Ethereum virtual machine, right? So the kind of most dominant development ecosystem in existence at the moment. If you learn Solidity, that helps you essentially also address any kind of EVM compatible, so any kind of layer 2 or any other kind of blockchain that does translate into EVM. At the moment, Solidity is kind of like the most versatile language that you could use for that kind of idea. It's essentially a JavaScript-based language. There are others, of course, so you can use also Rust, and potentially investing into Rust would allow you to be a little bit more resilient for the future, because a lot more blockchains are choosing to write smart contracts onto using Rust. The easiest way to dip your toes into a development environment is through Remix at remix.ethereum.org. This is an environment that works fully online. But at the same time, if you want to develop a little bit more in-depth knowledge, I really recommend that you try the Get Foundry development environment, which allows you to develop knowledge using essentially your local machine. Foundry actually uses many local resources, right? So you're able to create your own Ethereum testing network. You're also able to launch your own kind of local Ethereum node, which helps you essentially deploy contracts. And of course, you can also use essentially your own close development environment to develop smart contracts right on your machine. I'll pause here to see if there are any questions. No, not so far. Okay. I'm potentially going a little bit too fast. And to kind of help you in a sense on your learning, the pathways I would propose is obviously the companion I've written, which I think is excellent. But if you want a much more structured kind of approach to things, you can look into Updraft, which was made by Cifrin. Cifrin is a collective and a company that specializes in security of smart contracts and security of applications. And I think that's really important, because a lot of the smart contracts that are developed really hold a lot of value globally. So it's very good to be security conscious. And then you can look at software development kits and APIs through Alchemy. And a new player here is also Third Web. And of course, there is also the old Infura that allows you to deploy infrastructure within your own decentralized development environment. And that's the end of my talk. So if there are any questions, I'm happy to answer them. Okay, then I'll try to showcase our web companion then. And explain where people can find stuff. That seems more complicated than I thought. Okay, so this is the ArchiDAO Ethereum Development Companion, and essentially takes you through setting up a development environment in whatever operating system you're using. It discusses review of blockchain technologies on a basic level, then blockchain basics, more for cryptography, Merkle trees, and so on and so forth. And then we jump into Ethereum primitives. So how exactly does Ethereum work? And then we jump a little bit into traditional and decentralized application development. So the differences between the two. Then we move on to Solidity fundamentals. Then on to writing smart contracts. And then token standards and the Ethereum improvement proposals are discussed. And then we go on to Web3. So how do we go beyond smart contracts? We discuss essentially how to develop a full decentralized application. Testing, obviously, how to write unit tests. And then we go on to frameworks and some of the learning guides that you can find, for example, Alchemy University, learning through gamification, and then on to video guides and full stack development tutorials. And probably that didn't work. And any more questions, please? Perfect. Thank you all for your attention. I'll just go back to my slide here. And should you wish to contact me, you can find my website on dounas.xyz. Goodbye and enjoy the rest of Code Week. And I'd like also to thank Kariera for inviting me to the States. Thank you very much.